Now, we're going to take up one more problem on projections of lines, problem number 49. It is very similar to this previous problem which we have solved in our previous video, except there is small change in the dimension. A line capital AB has its end capital A is 20 mm above HP and 15 mm in front of VP. The other end B is 60 mm above HP and 45 mm in front of VP. The distance between end projectors is 70 mm. Draw its projections and determine the apparent length and true inclinations. So he has given. So there we were finding out the true length and only apparent inclinations. But here we are finding out apparent length and true inclinations. So now to find out this, so here first we are going to analyze this problem in 3D. A line has its end, a line capital AB has its end A 20 mm above HP. So when you look from the front view, I can see the distance above HP. So when it is projected, that will going to fall on the vertical plane here. So you mark this point as A dash and capital A. And 15 mm in front of VP. So when you look from the top view, we can see the distance in front of VP, which is 15 mm. So that when it is projected, it will going to fall on the horizontal plane. You mark this point as small a and capital A here. The other end B is 60 mm above HP. So when you look from the front view, we can see the distance above HP of 60 mm. So then draw a locus of B in the front view and 45 mm in front of VP. So when you look from the top view, I can see the distance in front of VP. That distance when it is projected, it will going to fall on the horizontal plane. So we will going to get this will going to be the locus of B in the top view. So but we know the distance between the end projectors is 70 mm. So from here you have the distance of 70 mm, which can be seen both in vertical plane and as well as in the horizontal plane. So from here you measure the distance of 70 mm and draw a vertical projector in the front view and also draw a projector in the top view also. Both will going to intersect at the locus of B in the top view and the locus of B in the front view. So you mark this point as small b dash and you mark this as small b, then join A to B with a dark line and join A dash B dash with a dark line. So when you project from B dash and also when you project from B, small b, both will going to intersect at this point. So you will going to get this point, this line capital AB, which is in space. Now we need to find the true length in the front view. So to find the true length in the front view, I need to take the top view now. So where is the top view? The top view is small AB. So this is in 3 dimension. We have capital AB with A center taking the radius of AB. You rotate that B such that capital AB1 is parallel to VP. That means capital A is in front of VP by 15 mm and capital B1 is also in front of VP by 15 mm. Then only the line will be parallel to VP. Therefore, you are getting the true length in VP. So when this line is projected, you will going to get B1 dash here. So you will going to get B1 here. And this is capital A, join A dash B1 dash with a little bit thicker than XY line. So this is how you will be able to find the true length in the front view. So how do I know that? So when you are projecting that line in space, but what happens to the image in the horizontal plane as we look from the top view? So B is here. So with A center taking the radius of AB, you rotate that B such that B1 will also be in front of VP by 15 mm. So AB1 is the line which is parallel to XY line in the top view. So obviously its corresponding front view will going to be A dash B1 dash, which will be in true length. So this is how we will be able to analyze this. So you measure, this is the apparent true inclination with respect to HP, which is theta. So that theta we have recorded here. And then similarly, I want to find out the true length in the horizontal plane. To find the true length in the horizontal plane, you have to take the front view. So we have to take a line capital AB, a front view line which is inclined to HP. So you make it parallel to HP. So to make it parallel to HP, with A center taking the radius of capital AB, you rotate it such that both A and B is above HP by 20 mm. So when you are trying to do in space, when you are trying to rotate in space, then what happens with respect to the image? So if the image in the front view is also gets rotated. How? With A dash center taking the radius of A dash B dash, you are rotated such that both A dash and B2 dash will be above HP by 20 mm. Then only the line will going to be parallel to HP. Since the line is parallel to HP, so which is that line capital A, B2 is the line parallel to HP. So when it look from the top view, it is projected onto B2, which is going to be the locus of B in the top view. So you mark this point as small AB2. small b2, then join small ab2 with a dot line with a little bit thicker than the continuous with the xy line. So then you can measure the inclination with true inclination with respect to VP. So you measure that it has phi, and also you measure the front view distance, which is a dash b dash, and the top view distance, which has AB. So that is AB is 76.12 when it is doing it in computer. When you're doing it in manual, it will be 76, and A dash B dash is 80.63, and A dash B dash will be equal to 81 mm when you're doing it in manual. So this is how we will be able to analyze this problem in 3D. Now we will try to take it by individually. Suppose if I want to find out the true length in the front view. So to find out the true length in the front view, I need to take the top view now. So where is the top view? The top view is here. So with A as center, taking the radius of AB, you rotate it such that both A and B1 will be above, will be in front of VP by 15 mm. So what happens to the image in the top view? The image in the top view, AB, is being rotated such that both A and B1 is in front of VP by 15 mm. Now the line is parallel to VP. Since the line is parallel to VP, so you are getting the true length in VP, which will going to be A dash, B1 dash. So this is the line which will going to be the true length, and you measure and denote that angle by inclination with respect to HP as theta. So when you are doing it in orthographic view, you can see here with A as center, taking the radius of AB, you rotate it, make it parallel. That means AB1 is parallel to XY line in the top view. Therefore, its corresponding front view will be in true length. So that means A dash, B1 dash is the line which will be in true length. Draw a projector from B1 to the locus of B in the front view. So you will going to get the line join A dash, B1 dash with little bit thicker than XY line. So you will going to get it as A dash, B1 dash. So since this line is parallel to VP, so you are getting the true length. Therefore, you mark this as capital A and capital B. So find out the inclination theta, which is 27.71 or 28 degrees when you are doing it in manual. And then A dash, B dash will go to be 81 mm. So similarly, what happens when you want to take the true length in the horizontal plane now? So to find the true length in the horizontal plane, you have to take the front view now. So where is the front view? The front view is here. So you take with A as center, taking the radius of AB in space, you rotate that line such that both A and B are above HP by 20 mm. Since it is rotated such that both AB2 here, that B2 is also above HP by 20 mm. So that this will going to become parallel to HP. So when you're looking in the top view, so it is projected onto the horizontal plane. So you're going to get small b2 and join small ab2 with a little bit thicker than the xy line. So you measure that inclination which will go to be VP. True inclination with respect to VP is fine. So this is how. But actually what happens when you're rotating in space, what happens to the image? The image in the front view, so that is A dash, B dash, is also rotated such that both A dash and B2 dash will be above XY line by 20 mm. So now it is parallel to XY in the front view. Its corresponding top view, which is AB2, will be in true length. So when you're doing it in orthographic view, with A dash as center, taking the radius of A dash, B dash, you rotate it such that both A dash and B2 dash is above HP by 20 mm. Since it is parallel to HP, so you're getting the true length in HP. So draw the projector from B2 dash to the locus of B in the top view, then join AB2. So since this line is parallel to HP, so you are getting the true length in HP. So you measure the inclination phi with respect to VP, which is being recorded here. So this is how you will be able to analyze this problem in 3D and also in orthographic view. Now we will going to try to solve the problem by using sketchbook. So first what we will do is, first we are going to draw the XY line, and you mark VP and HP, which is as shown. He says that NDA is 20 mm above HP and 15 mm in front of VP. Above HP is seen in VP. So VP is above XY line. So from XY line, you measure 20 mm above XY line and then draw a horizontal line. Similarly, 15 mm in front of VP. So from XY line, in front of VP is seen in HP. HP is below XY line. From XY line, you measure 15 mm below XY and then draw a horizontal line. Then with consider any point and draw a vertical projector so that both it will going to reach, both will going to touch us these newly drawn two lines. Then mark this point as A dash, and you mark this point as small a, and you mark this as capital A, and you mark this as capital A. Similarly, you take other end B is 60 mm above HP. Above HP is seen in vertical plane. VP is above XY line. So from XY line, you measure 60 mm and draw a horizontal dash dot line, and you mark this as the locus of B in the front view. Similarly, 45 mm in front of VP. So in front of VP is seen in HP. HP is below XY line. From XY line, you measure 45 mm below XY and draw a horizontal dash dot line, and you mark this as locus of B. Then we know that the distance between the end projectors is 70 mm. So from this projector A, you measure the distance of 70 mm and draw a vertical projector so that both the ends of the line will going to cut the front view locus line and the top view locus line of B, and respectively, and mark this point as small b dash in the front view, and mark this point as small b in the top view. Then join A dash B dash with a dark line and join A to B with a dark line. Now we need to find out the true length in the horizontal vertical plane. So to make that true length in the front view, obviously we need to consider the top view. With A as center, taking the radius of AB by using the compass, you draw an arc such that both A and B1 will be above in front of VP by 15 mm. Now the line is parallel to VP. Since the line is parallel to VP, so you are getting the front view in true length. So therefore, from B1, you project a vertical projector so that it will going to cut the locus of B in the front view, or mark this point as B1 dash. Then join A dash B1 dash with little bit thicker than the XY line. As we know that the top view line is parallel to XY, its corresponding front view will be in true length. Therefore, you mark this as capital B here. Then we need to find out the true length in HP. So you make the line parallel to HP. Which is the line which have to be made parallel to HP? The line which is inclined to VP. Which is the line which is inclined to HP? The line which is inclined to HP is the front view. Then take with A dash as center, taking the radius of A dash B dash, rotate it such that B2 dash is also above HP by 20 mm. So once you make that, you get A dash B2 dash is the line which is parallel to XY in the front view. Obviously, its corresponding top view will be in true length. So from B2 dash, you draw a vertical projector such that it will going to cut the locus of B in the top view. Then you mark this point as B2. Since A dash B2 dash is parallel to XY, its corresponding top view, that is AB2, will be in true length. So therefore, you mark this as capital B and join A and B2 with a little bit thicker than the XY line. So then identify this angle as phi. So by using the scale, you measure the distance from A dash to B dash, it will be 81 mm, and from A to B, it will be 76 mm. So then again by using the protractor, you measure an angle of with A dash as center, then you measure an angle of theta, which will going to be 28 degrees, and with A as center, taking with A as center, measure the angle with respect to horizontal, so that you will going to mark this point as phi, which is the true inclination with respect to VP. So it will be 20 degrees. So this is how you will be able to solve this problem and show all other dimensions and show all other dimensions. So this is how you will be able to solve this problem by analyzing and also by manual drawing by using the sketchbook. Thank you.